This video considers examples which involve world travel. There's not a lot of new learning that's needed for this, as these examples just put together all that we've learnt in the world geometry topic. You might like to pause the video in a moment and look at this worked example in full, but briefly just first take in the steps that are involved. We are asked to find the estimated time of arrival of a cruise ship, given the locations of its starting and finishing ports and its speed. The first step is to find the relevant time zones of the locations involved and the difference in zone time. Then we use an appropriate formula to find the distance between the two locations. The time taken for the journey can be found using the formula time equals distance over speed. The estimated time of arrival is then determined by taking the departure time, adding the travel time, and then allowing for the time zone difference between the places. We'll work on some of these examples together. This is another estimated time of arrival question. First, we'll find the difference in zone time. Take Los Angeles longitude, 124 degrees west, divide it by 15 and round it to the nearest whole number. That's 8. And because Los Angeles is to the west of the prime meridian, Los Angeles is 8 hours behind Universal Time Coordinated. Tokyo's longitude is 139 degrees east. Divide it by 15 and round to the nearest number, that would be 9, and because Tokyo is to the east of the prime meridian, Tokyo is 9 hours ahead of UTC. In all, Tokyo will be 17 hours ahead of Los Angeles. Now we find the distance. Two things that you should have noticed in reading this question. Firstly, the speed of the jet was given in kilometres per hour, which means that we need to find the distance in kilometres. And secondly, the jet was flying directly westward. This means that it was not on a great circle route. For distance east-west in kilometres, we need to use the formula d equals 2 pi r cos alpha times theta over 360. Alpha is the latitude of travel, 36 degrees, and theta is the difference in longitude, which we can find by using a plan view diagram. Tokyo is 139 degrees to the east, Los Angeles 124 degrees to the west. Flying westwards from Los Angeles will mean anti-clockwise in this diagram, so the angle theta will be as shown here in red. It can be found by totaling the longitudes and then subtracting from 360 degrees. Theta equals 97 degrees. Substitute into the formula to find the distance. The travel time can be found using the formula time equals distance divided by speed. And to find the estimated time of arrival, start with the departure time, 5:15 p.m, add the travel time, 11 hours and 38 minutes, then, in this case, add the zone time difference, as Tokyo is 17 hours ahead. It will arrive at a local time of 9:53 p.m. on Thursday. It's worth noting that the international dateline was crossed in this question, but the international dateline does not affect our calculations, as time zones automatically allow for the international dateline. The next example is an extended problem involving 3 locations, but the method is similar. Start by finding the zone times of the starting point and the destination. Divide Hobart's longitude by 15, round to the nearest whole number, 10, and because Hobart is east of the prime meridian, it is 10 hours ahead. And divide Honolulu's longitude by 15, round to the nearest whole number, 10, but because its longitude is west of the prime meridian, Honolulu is 10 hours behind. All in all, Honolulu is 20 hours behind Hobart. There are 2 separate legs of travel involved in this journey, and the distance of each must be calculated. The question says that the travel between Hobart and Christchurch is directly due east, so we're going to be using the formula d equals 60 cos alpha times theta to get our answer in nautical miles. A plan view diagram will help establish the angle theta subtended by the journey. Hobart is 147 degrees to the east and Christchurch is 172 degrees to the east. The angle difference can be found by subtraction. Theta equals 25 degrees. Substitute into the formula to find the distance in nautical miles. The second part of the journey involves travel on a great circle, so this is the formula to use. The longitude difference can be established with the aid of a plan view diagram. Christchurch is 172 degrees to the east, Honolulu is 157 degrees to the west. The angle involved can be calculated to be 31 degrees. Substitute carefully into the formula to find that theta equals 70.07 degrees. Now we can use our distance equals 60 theta formula to find the length of the second leg in nautical miles. Add together the two distances to find the total length of the journey. Find the total time spent flying by dividing the distance by the speed of the plane. Then add 2 extra hours to allow for the stopover. To find the estimated time of arrival, start with the departure time, add the travel time, and then, in this case, subtract the time zone difference because Honolulu is 20 hours behind. The plane will arrive at 6:39 a.m. on the same day. Notice how this answer somewhat curiously demonstrates how it's possible to arrive at a time even before you depart.